Welcome everybody. Today we're going to talk a bit about fracking, and we're going to talk about it within the scope of Milligan's mission statement, which here's a section of it here. Basically, we're here to learn how to change lives and shape culture through a commitment to Christian leadership, and that often means needing to take leadership both in our communities, in our state, in the nation, and voting on important issues according to our Christian understanding and Christian worldview. So, basically, oftentimes we want to know what is the most loving option, both for our neighbor and for our communities. And while sometimes that's obvious, other times it might not be so obvious. And so in the case of fracking, there's a few nuanced parts of this that we need to sort of understand in order to make these decisions, in order to truly love both our neighbor and love God and be good stewards of creation. So, in a lot of these areas where fracking takes place, and you folks have watched those two fracking videos earlier, and so you know a bit of what fracking is, we're in these regions where fracking has taken place. There's tends to be folks who have owned a lot of land, but this land hasn't historically been worth very much. Now, with fracking coming in, these folks can stay on their land, use their land, but they're able to sell off the mineral rights, and so they're able to make quite a bit of money on land that wasn't too productive before, and actually bring themselves up out of poverty. And so fracking has this benefit of economically helping folks that might really need it. Additionally, the electricity that you folks are using now to watch this video, it's cheap in part because of cheap natural gas from fracking. And so fracking not only helps folks who own the land that fracking takes place on, but also it makes energy cheap and is an excellent alternative to coal or having to import oil. There's also negative consequences we have to take into account when looking at fracking. Things like drinking water contamination, issues with siltation in streams, and so we can't ignore the possible negative consequences associated with any fracking operation. So we have the positives, helping bring folks out of poverty, but also the negatives and the environmental impacts. And I'll talk a little more about those environmental impacts. So, when we want to make a decision about what is the most loving thing to decide when we are asked to vote in our communities, in our states, counties, the country, there's a lot of unknowns. And hopefully as we walk through some of this information, that there won't be quite as many unknowns, or you folks will at least have the ability to go find out the information you're going to need in order to make these decisions. So here's a map of shale in the U.S., and there's quite a bit of oil and natural gas up here in North Dakota. I was talking to Chelsea earlier, and she said she knew someone up here who was able to sell their mineral rights. There's a bunch of fracking going on down in the Barnett Shales in Texas, and Fayetteville, and Arkansas, and the Marcellus Shale up in Pennsylvania is producing quite a bit of shale gas right now. And here's the Chattanooga Shale that comes right across eastern Tennessee here. And so we'll be talking a little bit about the Marcellus, which is up here, and a lot about the Chattanooga, which is here, right down here in Tennessee. So, this would be a good place to pause the video and ask students or whoever is there with you right now what they know about fracking and what are their opinions about fracking. What are their opinions based on? Alright, so now that you've had a little bit of a discussion, I'd like to talk a little bit more about some of the environmental concerns surrounding fracking. So there's two major areas where environmental impacts are possible. That's pad construction and in the drilling and the extraction. So first off, with pad construction, you can see there's a whole lot of digging and large vehicles, erosion that's involved with pad construction, and so you have a lot of this heavy truck traffic, artificial night lighting, loud noise, erosion. The silt can be washed down into streams and completely change stream ecosystems. And you see here, these are all drilling pads, and you see how all these drilling pads can really influence how an ecosystem develops. And we'll talk a little bit more about how this fragmentation might affect some things that we care about. And here you can see some trucks at a pumping station, basically helping to inject that fracking fluid that you learned about in those videos earlier down into the well in order to extract the gas. And now drilling and extraction, water use can be a huge, where there's a lot of fracking fluid used, water use can be a huge issue. It's not so much here in Tennessee, and we'll talk about that a little bit more. But we also have drilling accidents, so just like drilling for oil down in the Gulf, you can have a lot of accidents drilling down there, like we saw with it would have been a couple of years ago now. You can also have these accidents happening on land here with fracking. You also run the risk of water contamination, so both leaks in casings, which you saw an example of that in one of the videos you saw earlier, but also when in dealing with fracking fluid at the surface, you may mishandle fracking fluid at the surface. It could run off and get into groundwater, lakes and streams. The air emissions associated with fracking, they're both with the fluid, but also with the natural gas that's being bled off of some of these wells, and earthquakes. So there are fault lines underground, and you've got them here in Tennessee, and we'll talk more about that in a little bit. But the fracking fluid can actually get into these faults and lubricate the faults and actually cause them to move, and you can get earthquakes happening. And even so, when you blow apart the shale layers down underground while you're fracking, you can end up again shifting rock layers, and you can get these earthquakes happening. And this has actually been shown to happen, especially in the Fayetteville Shale in Arkansas. We've been seeing these. So most people are concerned about groundwater contamination. For us to talk about groundwater contamination, we first need to describe what groundwater actually is. And some folks might have heard that groundwater and aquifers are underground lakes and streams. Well, that's not actually correct. An aquifer is really just a rock that's full of water, and so it's more like a sponge. So if you look at different rock types, shale, sandstone, and limestone, you see that they differ in both porosity and permeability. And so porosity is the number of spaces in a rock. So Swiss cheese would be highly porous compared to cheddar cheese. And permeability is how connected these different pores are. And so if all the pores are connected, water is actually able to flow through rock. So you can hear shale. Shale has a bunch of tiny pores. You see them all over. But these pores, so shale can have a high porosity, but shale's permeability is quite poor because these pores, or shale's permeability is quite low because these pores aren't very connected to one another. Whereas sandstone, you see the porosity, there's a lot of space in between the sand grains, and so it's high porosity and high permeability. You can see that you have the ability of fluid to flow all the way through this sandstone. And limestone is actually a bit of a wily rock as far as figuring out porosity and permeability, because sometimes there's big old caves down here around Tennessee, and these caves are from water eating limestone away. And so these caves are large pores in the rock, and you can also have high permeability. You do have streams flowing through some of these pores in the limestone. But if the limestone hasn't been eaten away, then it can actually have really low porosity and permeability. So limestone can run the whole gamut from high porosity to low porosity, and also for permeability. So if you were to decide if you wanted to sink a well to pump water out of shale or sink a well to pump water out of sandstone, I would pick sandstone because remember, when you have a well, you want to be able to draw water from the surrounding rock. You don't want to just draw water where the well goes down. So if you sink it down into sandstone, you'll be able to you'll be able to pull water from the sides because of the high permeability. Whereas shale, if you sucked out what was in this pore, you basically couldn't get at any other pores. The water wouldn't migrate, and so pretty low permeability there. So now that we know how water behaves in the ground and basically how groundwater works, we're going to talk a little bit more about hydrocarbons and oil and gas. So oil is a fluid just like water, and so it follows similar rules to water. So here's a diagram of the subsurface, and just for your reference, that dotted blue line is the approximate location of the groundwater table, and so you wouldn't really see much groundwater below that blue line. And so this is to emphasize that most fracking that goes on is going to happen way below the water table. And so before we were doing fracking, we used these conventional wells. And in this diagram, this dark gray rock layer, this is where the oil and gas is coming from. And here you have a sandstone layer, and we know from our discussion of groundwater that sandstone is really good at having fluids being within it and move around it. So sandstone's a really good sponge for fluids. And then let's assume this gray rock, this seal rock, is just another layer of shale. So basically fluid cannot flow from here up to here because this layer is impermeable. And so because you have that and you have these structures, you end up with gas collecting in both this curved structure here, but also you see where these layers pinch together over here. You also have gas collecting up here. And so this is where most of the time where we would be able to pull gas out. Conventional well, we'd identify these structures using subsurface mapping, sink a well down, pull out the gas from the reservoir rock. Here it's sandstone, just like we would water from the groundwater, and we would basically be done. But now with fracking, we're able to actually drill directly into the oil and gas producing rock layer, blow it apart, and then suck the gas up. And then once that well's done producing, we can move on down to the next area and do it again. So just like there's reservoir rocks in groundwater, we've got reservoir rocks and seal rocks with natural gas and fracking. That's just to let you know a little bit more about the subsurface. Remember all this subsurface geology because you're going to need it at the end in order to describe what's going on here in Tennessee. So before we talk about Tennessee, I want to compare it a little bit to the fracking that's going on in Pennsylvania because they're two pretty different styles of fracking, and that's because of the subsurface geology. So as you take a look, you notice a huge difference already. So in Pennsylvania, you have this huge amount of rock, 14,000 feet of rock that lay over the Marcellus Shale. Whereas in Tennessee, you have just 4,000 feet of rock that overlay the Chattanooga Shale. So there's a lot of heavy rock sitting over this Marcellus Shale. And so because of that, they've got to use fracking fluid and a lot of it to build up enough pressure to blow this rock up. Because remember, there's a lot of weight sitting on this rock. Whereas in Tennessee, the Chattanooga Shale doesn't have near as much weight on top of it, and so they mainly use nitrogen gas. And so this nitrogen gas is very safe compared to the fracking fluid. The fracking fluid has some nasty chemicals in it. You got to be really careful how you handle it and where it goes. Whereas nitrogen gas, our current atmosphere is full of nitrogen gas, and so we're not really worried of that gassing out into the atmosphere. In Tennessee, they still use some fracking fluid in order to blow apart the Chattanooga Shale, but not near as much as they're going to use in Tennessee. Now, the other big difference is that in Pennsylvania, they're way below the water table. They're 14,000 feet deep, Whereas in Tennessee, only 4,000 feet, that's getting pretty close to the water table, actually, compared to Pennsylvania. So, a couple important differences to keep in mind. So, if we take a look at the Chattanooga Shale, it runs from northern Alabama all the way across to southern Kentucky, across this portion of eastern Tennessee. And this is these are the counties that have been producing oil and gas in Tennessee. The darker counties are where more oil and gas are produced. And you can see over here by Milligan, there's oil and gas production going just a county away. And here's the University of Tennessee, and this is the Cumberland Forest. So the University of Tennessee wanted to use the Cumberland Forest as an experimental field site to see what the effects of fracking are on the environment in this particular area, because geology changes so much from area to area that it's important to test things out before you actually do fracking in that area. So UT wanted to test that out, and basically there's a video here that I want you folks to watch. And so if you pause this video and go to this link, you folks are able to see this news story about what actually happened between UT and the public and the use of public land for this fracking experiment. So go ahead and pause the video and go to this link. So after watching that news story, I was wondering what you folks thought. What are some initial reactions that you have about what happened in this story, or what you learned in this story? Go ahead and take a few minutes, pause this video, and talk amongst yourselves about your reactions. So the Cumberland Forest subsurface geology is an important aspect when considering whether or not there should be fracking on the Cumberland Forest. Because as we talked about earlier, the subsurface geology is pretty important as far as what hazards you're concerned about. So this is a basic map of this is a basic cross-section of the geology of the area. And so remember we described shale, limestone, and sandstone earlier, and so these are the terms that we're going to be using here. And so here's the Chattanooga Shale. It's got some shaly limestone underneath it, so just a mixture of shale and limestone. So here's the Chattanooga Shale. This is what folks are wanting to blow apart to extract oil and natural gas from. Just above it, you have sort of a silty shale with chunks of limestone in it. So these triangles are chunks of limestone within a silty shale. And then you have this thick layer of limestone above that. And then above that you have these thin layers of shale, these black thin layers of shale, and this blue material is limestone, and so you have layers of shale stacked in the limestone. And then above that even you have sandstone with thin shale layers throughout the sandstone. And so remember, this is about 4,000 feet deep. And so this is the subsurface geology that folks want to frack within underneath the Cumberland Forest. So I really want to know what you folks think about fracking in the Cumberland Forest and East Tennessee in general. And so in order to make those decisions, I want to just key you in on a few important aspects of our sort of the ecology and geology of the area before you consider the effects of fracking and whether or not you think it's a good idea. So these are the general concerns, again, that we covered earlier. And I just want to temper this by having you remember that there's also a lot of financial gain and a lot of positives associated with fracking. And I also want to emphasize that just because folks are concerned about these things don't necessarily mean that they're going to cause a problem. So drilling accidents, for instance, are always going to be an issue, right? But we're okay with drilling for oil offshore because we don't often have accidents happen, and so we're willing to deal with that, what we've considered a small or acceptable risk in order to achieve benefits. And same thing with water contamination. By and large, there haven't been any measured instances of water contamination due to fracking in Tennessee. Now, there is always a chance of that happening, but your decision is or your task is to decide whether or not that chance is outweighed by the benefits. So just something to keep in mind. Just because there are concerns or there are potential issues, they may not be extreme. For instance, we get in our car every morning, we decide that the chance of getting in a wreck is small enough that we're willing to drive. So, cost-benefit analysis. So, we're pretty blessed here in East Tennessee. We've got a biodiversity hotspot, and so we have a whole lot of biodiversity in the area. And I mentioned earlier that fragmentation from fracking pads could affect biodiversity in the area, so that's just something for you to keep in mind. So something I want to remind you of so here's these fracking pads, and they're within an agricultural and forest sort of system. And so as you add these fracking pads, you're going to increase the possibility of siltation, and you're also going to be decreasing the forest plot sizes. And so you may be changing biodiversity. Some animals might leave because they don't like those small forest plot sizes. Other animals might stick around. And this actually starts to become pretty important when you consider tick-borne diseases. And so you can see Tennessee has quite a bit of Rocky Mountain spotted fever. And since 1993 to 2010, Rocky Mountain spotted fever has increased quite a bit, and it's a problem because even with current drug treatments, Rocky Mountain spotted fever is still fatal in between 1% and 5% of cases. So it can be a pretty serious issue. And so for Lyme disease, what folks have found out is that if you have a plot of land and you cut the forest, and if you cut the forest and the ag land into pieces, so that, say, for instance, we take a checkerboard, and the black squares are ag and the red squares are forest. If you cut it into that checkerboard pattern, you have a much higher risk of getting Lyme disease in that kind of ecosystem than if you were to just divide it half forest, half farmland, so two big chunks. You have less disease risk than that checkerboard pattern. And so that could be important considering that fracking can actually cause that checkerboard pattern. So that's just something for you folks to keep in mind. And I should mention that there are a couple seismic zones in eastern Tennessee, and so earthquakes may or may not be an issue. Again, sort of a cost-benefit analysis. Is the risk worth the benefits, or is the risk too great and the benefits too small? So, I would really like for you folks to answer, first off, do you think that the fracking experiment in the Cumberland Forest is a good idea? The fracking experiment they talked about in the news video. And back this up with scientific knowledge that you have gained throughout this talk, and some things you might have known earlier. So, there are opinions on both sides of the issue. I just want you to be able to back up your opinion with scientific concepts. So, do you think it's a good idea for the fracking that UT wants to do in the Cumberland Forest to go ahead, or do you think it's a bad idea? Why or why not? Also, I'd like to know if you folks think that is fracking in East Tennessee in general a good idea? And again, back that up. Why or why not? There's opinions on both sides, so you cannot have an incorrect opinion as long as you can back it up with scientific reasoning. And as with all things, there are some pieces of information that might be really useful in order to be able to answer this question. And so what kind of information would you like to know about this system in order to make an even better decision, because I definitely haven't provided you with all the pieces that you would need in order to make the best decision possible. So that's the end of this lecture. If you want to pause the video so that students might have this slide up on the screen and let them answer these questions, have some group discussion, and it'll be interesting to see what you folks come up with. All right, thank you very much.